As you start to solve additional literal equations or formulas, you may start to recognize some of the formulas that you encounter. Our next example is to solve the formula F equals 9/5 C plus 32 for C. You may recognize this as the formula that correlates temperatures in degrees Celsius to temperatures in degrees Fahrenheit. Given an individual temperature in degrees Celsius C, you can then multiply by 9/5, add 32. It would then in turn give you the temperature in degrees Fahrenheit. This is a useful formula for somebody to have if they are traveling from the United States to a country where the temperatures are usually measured in degrees Celsius. They would be able to convert the temperature in degrees Celsius to the temperature in degrees Fahrenheit and be able to understand what the temperature is in a system they're more used to. Somebody in Europe would be more comfortable looking at temperatures in degrees Celsius, so when they encounter temperatures in degrees Fahrenheit, this formula will not help them. They would need this formula resolved for C so that they could take a temperature in degrees Fahrenheit and in turn calculate the temperature in degrees Celsius. The first step in solving this formula for C is to recognize the variable term we are first trying to isolate is the 9/5 C. Since that's what we need to isolate, we need to remove the plus 32 from the right side of the equation. The opposite of adding 32 is subtracting 32. As always, when we subtract 32 from one side of the equation, we must remember to do it to both sides. Simplifying each side of the equation now, we're left with F minus 32 equals 9/5 C. The final step in solving this equation is to eliminate the coefficient of 9/5 on the C. Since we're multiplying by 9/5, I could divide both sides of the equation by 9/5 as well. But I also recognize dividing by 9/5 is really the same thing as multiplying by 5 over 9. So I will multiply both sides of the equation by 5 over 9. A key thing with the multiplication property is that when you multiply a side of an equation by 5 over 9, for example, you must multiply everything on that side of the equation by the 5 over 9. Since our left side of the equation is f minus 32, when I multiply f minus 32 by the 5/9, the f minus 32 must be placed in a set of parentheses. Over on the left side of the equation, we're left with 5 over 9 times in parentheses f minus 32. On the right side of the equation, the 9/5 times the 5/9, the 9s and the 5s all cancel, and it leaves us with C. So we have now solved the formula for C. Some people would be inclined to stop here, as they've just done what was directed. They've solved the formula, they've solved the equation for C. Others would be less inclined to stop here because they don't like having parentheses left in their answer. So some people might be more inclined to take that 5/9 f minus 32 in parentheses and distribute the 5/9 into the parentheses. If they were to do this, they would have 5/9 times f minus 5/9 times 32 equals C. And then simplifying that, you'd be left with 5/9 f minus 5/9 times 32, which will treat as 32 over 1, leaves us 160 over 9. The truth is, both this answer, 5/9 in parentheses f minus 32 equals C, and 5/9 f minus 160 over 9 equals C, are both correct. It's also important to point out there was another option we could have used from the beginning of this problem. Our initial equation was f equals 9/5 C plus 32. Perhaps you noticed in the beginning we had a fraction that had a denominator of 5. We could have started all of our work by multiplying everything on both sides of the equation by 5 to clear out the fractions. 5 times f on the left side is 5f. Distributing the 5 to the 9/5 C and the 32, 5 times 9/5 C is 9C, and 5 times 32 is 160. So now we have 5f equals 9C plus 160. To finish solving this for C, I'll subtract 160 from both sides. That will leave me with 5f minus 160 equals 9C. And to solve 5f minus 160 equals 9c, I need to eliminate the variable's coefficient. I need to divide both sides by 9. And in turn, simplifying this, the 5f minus 160 all over 9 does not reduce, but the 9c over 9 does reduce down to c. And you'll notice we now have a third possible way of writing our answer. All three of these formulas are equivalent. If you take any value for f and substitute it in for the f in any of the three starred formulas, the 5/9 in parentheses f minus 32, or the 5/9 f minus 160 over 9, or the 5f minus 160 all over 9, put any value in for any one of those f's, and you'll always return the same value of c. One of the challenges of these formulas is that sometimes people will take different approaches, and so the answer at the end might not look the same on everybody's paper, or maybe even your answer compared to the answer you see at the back of the textbook. But the fact is they are all equivalent. You can verify that by picking different values of f and confirming that you do obtain the same value of c.